This is Cosmographia, the Randall Carlson podcast.
And welcome back, ladies and gentlemen, to Kosmographia, the Randall Carlson podcast. I am Russ. This is Kyle. We are Brothers of the Serpent. That's our podcast. And we are joined, as usual, by Bradley. Sir, how are you doing this week?
Hey, guys. I think I need a vacation from the isolation.
Need a non-hermit vacation.
Exactly.
Yeah.
Get out
Mike?
amongst people.
Yeah.
I'm here,
Mike, how you
guys.
doing?
Things are well in Atlanta. Had a big thunderstorm today, but it's drying out. And happy birthday to you guys.
Oh, thank you. Yep.
Well, you guys both had birthdays?
Yeah,
Russ's birthday.
Okay.
Yeah, it was my birthday.
Because I was, you guys were born on the same, you have the same birthday?
Oh, yeah.
You guys are twins?
No, it was Russ's birthday. Sorry.
Yeah,
Happy birthday Saturday.
Russ is 42 now.
that's right.
So it's all
Getting up there.
downhill from here, Russ.
That's what I've been told.
Mm-hmm.
An easy
Untrue.
cruise, right? Just hop on the skateboard and go. All
That's
downhill. So where were we at last week, Randall? We were talking about Greenland and nanodiamonds and Bull
Yeah,
Creek.
we've been talking about nanodiamonds, really little diamonds that have to be seen with transmission electron microscopy. So we were talking about, I think at the very end, we were talking about the Bull Creek site in Oklahoma. Isn't that what we were talking about? I do believe, yes. And there was an interesting paper that came out back in 2014, I recall, that I have read at the time and reread it just to become more up to date on what's been going on there. And apparently, as we discussed last week, you guys found an interview with the lead scientist, Leland C. Bement.
That's right.
And I think that why don't you go ahead and read that quote or whatever and whatever else you need for context.
Yeah. The article is basically talking about how they were looking for volunteers, Dr. Leland Bement, and they've been out there. And he says the site is interesting. He says, beneath the remains of an ancient bison kill and a separate prehistoric Paleo-Indian camp dating back some 9,500 years ago, at the 13,000 years ago level is a sterile zone, save for a massive influx of nanodiamonds. And the doctor says, generally we sample the dirt to get pollen and other remains from that time period, but we came across a zone that had no pollen. It was heavily eroded, but the amount of nanodiamonds there were spiked.
Mm-hmm.
So that really struck me that there's no pollen.
No pollen. No pollen.
It's not just culturally sterile, but there was no evidence of plant life at all, not even pollen. That's
Right.
wasteland, like you were talking
no
about.
No shrubs, no trees, no
flowers. Yeah.
Right, no flowers. A wasteland.
A wasteland.
And what else did they find there at that layer? The sterile layer was
A nanodiamond spike.
a lot of nanodiamonds, right?
Right.
Okay, this is in Oklahoma. But now there was something else interesting about this study. What was that, Kyle?
There was a second peak of nanodiamonds that was roughly 2,500 years before present, between 2,000 and 3,000 years before present.
Aha, yeah. That's interesting. He says the implications of the diamond investigations for the impact hypothesis. They were identified primarily as the N diamond structural form, which, because in these various kinds of nanodiamonds that are formed in these impacts events and possibly in other events, maybe volcanoes, is that they take different forms. The carbon allotropes. They can be the N diamonds, they can be I diamonds, they can be cubic diamonds, which are sometimes hard to distinguish from the N diamonds, but they can also be hex diamonds. So anyhow, they say that the search for nanodiamonds in 49 samples, ranging in age from the late glacial maximum, so dating back to about 20,000 years ago, all the way up to modern times, also included samples representing Younger Dryas-like environmental perturbations, sediments of alluvial Andeolian process, in other words, sediments that were deposited by water and by wind. Alluvial meaning water, flowing water, and Aeolian meaning by wind. So when they checked out these samples that they extracted from the site, they found that there was a nanodiamond spike during the 2,000 to 3,000 radiocarbon years before present deposits. He says, so the nanodiamond spike during that period is enigmatic. First, because the nanodiamond spike continues beyond the cultural layer to the modern surface. And second, because a smaller spike in nanodiamond occurrences was identified in the Hearth deposits of similar age. The Hearth site is a short-term camp dated to 2,540 plus or minus 40 radiocarbon years before present. I don't know what that would adjust to in calibrated years, but at that time, it's probably not far enough back for there to be a really substantial divergence between calibrated years and radiocarbon years. The cultural material included a fire hearth and a scatter of tools and bison bones. Sediments from below, at, and above this occupation level were scrutinized for nanodiamonds. So nanodiamonds were found in 3 of the 6 samples. So that would suggest, as they go on to say, if the Younger Dryas boundary and the late Holocene concentration, so the 13,000 year ago boundary, or 12,800 year ago boundary, and the, let's call it the 2,500 year boundary, if they cannot be attributed to specific depositional environments, pedogenesis, which is soil formation, periods of environmental perturbations or stability, or cultural activity, then some other nanodiamond producing or concentrating event or condition must have been present at these 2 times. If an ET, or extraterrestrial source or trigger, is to be considered for the Younger Dryas boundary spike in nanodiamonds, then similar consideration would be needed for the late Holocene spike. So what they're saying there is that it's possible that 2,500 years ago, there was some type of an impact that left a layer of nanodiamonds in that same region. But like in our earlier pre-show discussion, I think we agreed that it would have not been anywhere near as extensive or severe as the Younger Dryas event, clearly.
Yeah.
So it must have been a local event. And if it wasn't an ET event, if it wasn't an impact of a meteorite, bolide, whatever, then what could it have been?
Well, could it have been volcanic activity?
Well, now there's one of the questions. Does volcanic activity produce the heat and pressure conditions requisite for the formation of nanodiamonds? I don't think so.
I don't know.
I don't think so. I think we'll
Could
look
there be
at that.
nanodiamonds already in the volcanic material, like formed deep underground, and I'm just,
playing the devil's advocate.
Yeah. Like, what if the nanodiamonds are formed deep underground and then they're blown out in the volcanic eruption?
Well, sounds like a valid question to me.
Yeah.
But I think at the point, what I've learned up to this point is that I think it seems pretty clear that generally impact events would provide the pressures necessary. Volcanoes, I think it's an iffy proposition.
Right. That makes sense.
Yeah.
The other thing real quick, the other thing this article says when they're interviewing Dr. Bennett is that they took soil samples not only at different levels of Bull Creek, but also all up and down the Beaver River.
Yeah.
And that's where they came across the second nanodiamond layer. And this article, I mean, it's an article, it's not a scientific paper, so it says dating around 2,000 years ago.
Okay.
Roughly the same time that a meteor struck in nearby southwest Kansas. Mm-hmm. So around and roughly doesn't give you much.
No, it doesn't. And then the date for this hearth site that it's talking about here is 500 years earlier. So clearly, more precise dating would be necessary. See, that's a constant problem in all of this is the dating precise enough to correlate to unique events?
Plus or minus 2,000 years
is not very precise.
It's kind of hard to correlate events.
Yeah. So our findings also identical. Our findings also identified identical high quantities of nanodiamonds in late Holocene through present age deposits. But that's curious too. Of course, now that could be the result of bioturbation or tree roots redepositing. So, I mean, if you've got a layer of this stuff and it's near the surface, tree roots and organisms, burrowing organisms and all of that can really have a big effect plowing up the soil.
What did you call that? Bioturbation?
Bioturbation.
Ah,
yeah.
Great term.
Yeah, so you can add that now to your ever-growing lexicon.
Band names.
Kyle's writing. Bioturbation is a fantastic band name. Yeah, Kyle's writing it down.
Or so what's Kyle been up to? Oh, he's just been bioturbating.
That's right. Stirring up dirt.
Stir. Well, that's what we were talking about earlier in the pre-show is about Kyle playing in the dirt. Did he play in the dirt a lot as a child?
Yes.
Oh, yes.
He did? Mm-hmm.
Pretty much all the time.
All the time, yeah. He was definitely a bioturbator.
Kyle, what are you doing in your room? I'm bioturbating.
Hey, we were deliberately not going to go there, Mike. And then, of course, who has to go there?
Yes, you were.
Yeah.
No, I wasn't. I was moving on. So he's willing to say that the implication of this finding is that either a similar process for concentrating nanodiamonds.
Yeah, concentrating.
So I'm not sure how you would concentrate the nanodiamonds. Doesn't really explain where they came from in the first place.
Right.
Right. Was acting at both times or a similar event. That's what I would obviously think. A similar event that created the spike at the Younger Dryas boundary also occurred during the late Holocene.
Yeah, and again, in this article, they directly quote Bennett as saying that the fact that the second nanodiamond layer roughly dates to the same time that a meteor struck in nearby southwest Kansas, he says that seems to strengthen the argument that there was some sort of explosion over North America 13,000 years ago.
Yeah, so for anybody that's near Havilland Crater in Kansas, you should go check it out.
Yeah.
Yeah, go check it out.
It was identified in 1925. It's like, what did I say?
50 feet across.
50 feet in diameter, oval shape.
There is a meteorite fragment in a nearby museum thing. I saw a picture of it.
Strong iron or palisite type meteorite.
Mm-hmm.
And there's been a lot of different pieces and fragments found. And so they think that was actually
part of a fall.
Yeah, multiple meteorite fall.
Mm-hmm. Probably like a late stage fragmentation as it's coming in. It breaks into a dozen different pieces. Yeah.
That'd be a cool recon trip.
That would.
Sure would. And you guys are how far are you guys from that site? Let's see. Well,
we're like 10 hours from everything. We're in the middle of Texas.
Let's see here. We should go ahead and why don't you guys, would you have Google Earth open? Why don't we pull up the Guyman
Oh yeah.
and show that it was, they say in the article that it's about 30 miles northwest of Guyman.
There you go.
Yeah, there we are.
So Guyman is there on the lower right.
And then there's this dry creek formation here
Yeah.
running up here. And so I've just stretched this measurement out to 30 miles.
Can you
Yeah,
zoom
that's
in on the
exactly what
line
I
there?
did.
Yeah, there we go.
So you can follow the creek up there.
And zoom out a little bit so we can get a context there. Okay, there I see the Oklahoma-Kansas line. And then, in fact,
Yep.
that's Kansas-Colorado intersection right over there.
That's
isn't it?
right, yeah.
Right there, yeah. Okay, zoom in on the site and then click the 3D button down here in the lower right.
Pretty flat.
It's pretty flat, but you can clearly see, the erosion extends considerable ways out, maybe as much as a mile out from the creek itself.
Right.
So that's an eroded area. So that's most likely bounding the maximum flood extent through that particular creek valley right there. So that flooding might very well go back to, Pleistocene, Holocene transition.
Oh yeah. And there is a pretty big erosional feature farther west of all this that we were looking at.
Yeah, I was
in the
noticing
terrain.
that.
Yeah.
You might want to spin the red arrow to the north down here.
Well, didn't mean to do that.
Way out.
Yeah.
You wanted context, now you got it.
Yeah.
Yeah, there it is. There's your, yeah.
Yeah. Zoom in there on Kenton. Let's just take a look at that for a second. Not that that's related, so we won't spend a whole lot of time. Okay, now rotate. Hit your 3D. There we go.
Why does it always turn me like that?
I don't know, man. Google Earth
Wants you to
did
orbit.
something that got screwed up. We got to figure it out. But yeah, you can see, that's pretty impressive erosional feature
Oh,
there.
yeah.
You can always hit N on your keyboard to reorient north.
Hey, there's Black Mesa.
Thank you, Brad. Hey.
Well, that's
Yeah.
not Black Mesa, Arizona.
Okay.
But yeah, check out those bluffs. And check
yeah.
out that isolated upland area right there.
Yeah,
Yeah, that's some.
man.
So that's all that's left of the original landscape, probably.
That's
huh?
right. Yes, you got that right. Once upon a time, that plain of where it says Black Mesa Preserve, that level was much more, it continued right off the page there.
Wow.
What is that?
Yeah, that's not a strand line. That's a layer.
It's a layer of
it's-
something. It couldn't possibly be volcanic ash that thick.
Looks kind of chalky.
Yeah, it looks limestoney.
Looks like limestone, yeah.
Mhm.
A hard part of the limestone bedrock there. Sticking out.
Mhm. There we go. Yeah. It's a. Well, I'll tell you what. I'll meet you guys there tomorrow for lunch,
right.
and then
We'll
we'll
see you. We'll be there.
walk out there and we'll get some samples and see what we're looking at.
Do some bioturbation out there.
Well, yeah, we can do that too.
Any of the Patreon subscribers have a private access to a private plane, that would be nice.
Yeah. A helicopter is what we need.
Well, we'll be having one soon.
All right, good. Is it gonna say Randall on the side of it?
I hope not. Okay. So anyways, there we go. So here was so Leland Bement's article that I read, actually goes back. I've probably, to 2014. So it's over 6 years old now, but it's just one of the ever growing bodies of evidence supporting an impact. But now we get this,
And again, this interview was posted on February 9th, 2019. So he's still
he's
He's still going out to the site. He's still getting volunteers and working in it each season.
Well, here, what's interesting then to me is that he takes a much more conservative tone in the
paper.
2014 paper, yes, which was published. It was published, in the Proceedings of the National Academy of Sciences. Yeah. So he's interviewing there. He's had this is from 2019, so he's had 5 additional years of study.
Right.
And he's probably a whole lot more confident now about what he's found there.
Yeah.
Not only that, but he might be following the work of the
oh, definitely. It says
of the Comet Research Group.
Right. It says that they contacted him. Scientists who have been working on the theory that a sudden shift to a colder climate called the Younger Dryas event around 13,000 years ago in North America may have been triggered by an exploded comet. When they learned of the dead zone found at Bull Creek by Bennett, they contacted him.
Mm-hmm.
So
there we go.
Yeah.
Well, and then we had also talked about the nanodiamond rich layer in the Greenland Ice Sheet. Now that came from even earlier, which was 2010. We're going to do a share screen. So pull up this map of Greenland here. So there we go. Over on the right is the Greenland Ice Sheet, and you can see some of the various drilling projects that have occurred. They're named here. Camp Century and the Die 3 site were some of the earlier excursions, and they were done closer to the margin of the ice sheet, which actually did begin to disclose that there had been some pretty wild climate things going on. The problem was in those early days, 70s and 80s, their capacity to drill entirely through the ice sheet to bedrock was much more limited. So it wasn't until the late 80s that they developed the technology to drill through the whole couple of kilometers of ice over the summit of the ice sheet. And that was the JISP2 and the grip that you see right there at the center. And the reason they really needed to do that, because at the margins of the ice sheet where you see Camp Century and the Die 3 and these others by these other teams, near the margin of the ice sheet, the ice is a lot more dynamic. So it's much more difficult to get a precise chronology. Whereas when you go to the center of the ice sheet, the mass of ice is generally more stable. So you can actually count the annual layers. And where you can't actually count them by eye, you can use electrical measurements to determine, because each layer can, by the result of whatever is in those layers, the type of dust or lack of dust or whatever will affect the electrical conductivity of these layers. So they can use that to count layers. And I'm not fully proficient on that by any means, but there is ways, to accurately count the number of layers. Of course, the deeper you get, the more difficult it becomes. But so the JISP2 and the grip are the ones that came out, those first papers published in 1993 that were, to me, so groundbreaking, because they really did verify that the climate of the North Atlantic region anyway had undergone these extraordinarily fast and extreme climate changes at the end of the last ice age, and really did help to define and demarcate the Younger Dryas boundaries on both ends. So that right there is the Greenland Ice Sheet. But now I'm going to scroll down, because the way they had to do it for this was they actually had to go to the margin of the ice sheet where the 13,000-year-old layer was exposed at the edge of the ice sheet. And that's what it's showing in this diagram right here, is that you've got this dust layer showing that there was a much dustier period of time during the Younger Dryas. And that would make sense if you think about it, going back to, the wasteland concept, this idea that for 1,300 years, there was this decline in temperature where you'd had 3,000 years of this gradual warming, bringing, causing the ice sheet to shrink back. Now you had this catastrophic event at 12,900 years ago. And then, just as we found in the Bull Creek layer, which that area, that zone of sterility where it was sterile, was much more widespread. In fact, it was continental is what it appears like. So anyways, that if you don't have any vegetation, yeah, you're going to have a lot more airborne dust. I guess that's what I'm trying to get to.
Right.
So the two types of evidence sort of complement each other. So this Younger Dryas layer, is a much dustier layer that's been identified in the ice sheet. And at the bottom of that, where the red dots are, that's the nanodiamond peak layer.
So there's not a nanodiamond peak at the end of the YD, or at least they haven't pinpointed one yet, if there is.
Well, let's see. I'm going to show, let's see here. Not identified. I've got another, I'll do another share screen.
Because it is always a question to me, what ended the Younger Dryas as well? And, if
I know.
Nanodiamond.
Yeah, totally. That, to me, is one of the fundamental questions. I've got questions about the end of the Younger Dryas. I've also got questions about meltwater pulse 1A at 14.6.
1A, yeah.
What happened there? I would approach that from two perspectives. One, that the dating is correct, and there was something at 14,600 years ago that caused an extraordinary melting of ice sheet. I would think, because then that would obviously be associated with a rapid global rise in sea level. Then we've got the 12,900 event where the nanodiamonds are showing up, and then we've got meltwater pulse 1B, which is 11,600 years ago. What's the explanation there? It seems like we're kind of looking at a tripartite sequence of events that ultimately terminated the Ice Age.
Yep.
And at the center of this is this presumed ET event at 12,900 years ago. Here we have the nanodiamonds. Here we have the microspherules. But what happened at 14.6 and what happened at 11.6? So we've got a 3,000-year span, and then the second half of that is basically the Younger Dryas, which then ends at 11,600, and then that is usually taken now as the date for the beginning of the earliest stage of the Holocene.
Right. There's also the biomass burning is in there too.
Yes, I didn't mention that, but the biomass burning, which has been challenged, but I think has been sufficiently answered by the comet impact proponents. I think they have responded pretty effectively to all of the challenges and criticisms of the idea. But that's the way science works, isn't it? The way it's supposed to work anyway. I'm going to do another share screen here. Have a look here at this graph on the right, which is the vertical abundance distribution of nanodiamonds compared with a low resolution oxygen 18 delta oxygen 18 trench record that exhibits an apparent episode of cooling. And if we look at this graph, you'll see the green is the oxygen isotopes. Shifting to the left, it's going to be cold, right? So right here, you see this in the Greenland Ice Sheet, you've got the spike of nanodiamonds right here. And at that dashed line right there exactly, you've got this plunge in back into cold. So these two things correlate in time. How are they connected? That's the question. I don't see how the distribution of nanodiamonds itself is going to cause the cooling, or reverse of that the cooling is going to cause the deposition of the nanodiamonds. So it would seem to me logical that both the rapid cooling that you see here and the spike in nanodiamonds owe their origins to some third process.
Well, haven't you heard the slang term for diamonds is ice?
It is, isn't it?
It could cause the cooling, man.
Okay. Interesting. Okay. So here's what they have to say about this. So this project was done in cooperation with PBS Nova Documentary Productions, 2008, during which several authors sampled at a margin site east of Kongerlussuaq, I have no idea, Kongerlussuaq, West Greenland, approximately 1 kilometer inland from the ice margin. Our goal was to collect continuous samples of ice extending from the last glacial episode through the early Holocene, including the 1,300-year-long YD cooling episode. One of the authors has considerable experience sampling along the Greenland ice margin, and he identified a candidate for the Younger Dryas age section based on visual inspection of dust stratigraphy. Our sampling was guided by the presence of clear, dust-poor ice of assumed early Holocene age, stratigraphically higher than a sharp visual change into dusty ice of inferred Younger Dryas age, beneath which was another sharp change into clear ice of assumed Balling Alarod age. So that fits again with the idea of more airborne dust and contaminants in the air, which would then correlate with a decline in vegetation. So that's consistent with what we just learned about the Bull Creek episode. The final and preferred hypothesis is that the Greenland nanodiamond peak layer. Oh, and let me mention here the authors of this, Andrei V. Kurbatov. It's Kurbatov. He is with the Climate Change Institute, University of Maine, and Paul A. Majewski, also with the same institution. Now, Majewski, I might mention, did some early studies on the atmospheric, the unique conditions of the atmosphere during the Younger Dryas. We've actually have referred to Majewski early in one of the earlier podcasts. We should probably come back and re-reference his work. But he, I think as early as the early 90s, was identifying that something very anomalous was happening to the global atmosphere during the Younger Dryas. So this was pre-2007, so pre the introduction of the impact hypothesis. So he's with the and then we have Ted Bunch in there, and we have James Kennett, and it's quite a long list, including Kinsey. Remember Kinsey? We talked about him a few weeks ago. He says, we report the discovery in Greenland ice sheet of a discrete layer of free nanodiamonds in very high abundances, implying most likely either an unprecedented influx of extraterrestrial material or a cosmic event that occurred after the last glacial episode. From that layer, we extracted nanodiamonds and hexagonal diamonds, or Lonsdaleite, an accepted ET impact indicator at abundances of up to about 5 times 10 to the 6th times the background levels in adjacent younger and older ice. I think we read that last week, so I'm not going to get into that, but recently, scientists reported an abundance peak in nanodiamonds at multiple locations across North America that is restricted to a thin sediment layer, the Younger Dryas boundary layer, which dates to the Younger Dryas onset of approximately 12.9 thousand years ago. A peak in hexagonal diamonds was also reported in the Younger Dryas at Arlington Canyon, California, which we spent, I think, most of a podcast talking about Arlington Canyon. The only known explanation for terrestrial Lonsdaleite is by arrival inside extraterrestrial objects and or by impact of such objects with the Earth's surface. This discovery begged a prediction that a coeval layer with high nanodiamond concentrations should be preserved in the Greenland ice sheet. No layers of nanodiamonds have previously been reported from the Greenland ice sheet or any other form of glacial ice. Consequently, we on a section of the Greenland ice sheet that potentially spans the last deglacial in search of a layer containing an abundance of free nanodiamonds that might be coeval with that of the Younger Dryas boundary, a study that included both field and laboratory components. So the final, during our Greenland research, we also examined nanodiamonds extracted from the Cretaceous tertiary sediments collected in Caravaca, Spain, and Needles Point, New Zealand. What is the Cretaceous tertiary, or KT sediments? That would be the 66 million year ago dinosaur extinction event. And this is what is interesting, and I may have said this last week, but it's worth reiterating. The impact layers at both sites display substantial abundances of Lonsdaleite and diamonds, having the same morphology and range of sizes as those found in the Greenland samples. Since Lonsdaleite is only known to form during high temperature, high pressure cosmic events, its presence currently can be explained in only two ways. Either the Lonsdaleite arrived already formed within meteoritic material, or it crystallized during a hypervelocity impact with the Earth's surface. The rounded morphology, range of allotropes, and very high abundance of nanodiamonds in the peak layer appear to exclude the first possibility. Regarding a possible impact event, the Greenland nanodiamonds are identical to those found in the KT impact layers. So the presence of rounded diamonds and Lonsdaleite in Greenland ice suggests that a large cosmic impact occurred, and further investigations are necessary to determine the nature and scope of this event. In summary, since continent-wide layers containing nanodiamonds are only known to exist at the KT boundary and the Younger Dryas boundary, then the existence of this layer in Greenland ice appears consistent with the occurrence of a major impact event that correlates with the nanodiamond-rich Younger Dryas boundary in North America at 12.9 plus or minus 0.1 thousand years ago. So there we go. Now this is, yes, some of the familiar names have joined the team, but what we're seeing here is that additional scientists are signing on. And this, now we have Andrei Kurbatov. Mayuski is co-authoring this paper. We also have Thomas Stafford Jr. on here. What do you guys know about Thomas Stafford?
He did the research in Hall's Cave.
Yes. Now tell us a little bit about Hall's Cave to remind folks what that was or what.
Well, Hall's Cave is located right in our backyard here, Kerrville, Texas. And I guess they found that the opening to the cave allowed a place for the sediments to fall in and be preserved from erosion. So they've dug through the sediments and found them that go all the way back to the Younger Dryas period.
And beyond.
Yeah.
Back to about 20,000 years ago, I believe.
Yeah.
And they're preserved very well, which is pretty rare here. Everything's either heavily eroded or heavily flooded through. So
okay, so
now, one of the things I forgot.
So we have talked about this Hall's Cave in earlier episodes.
Yes.
And you guys actually communicated with Thomas Stafford, right?
That's right.
And now his role was what? He was lead archaeologist on the site?
Geophysicist or geologist.
Yeah. Okay, so he's a geologist. Yeah. Okay.
Right.
Yeah, which probably should say right here in this paper if I just referred to it. But
you just said, and I had completely forgotten this, that there is no known terrestrial origin for Lonsdaleite.
That's right.
Well, it's been found in Hall's Cave.
Well, that's what Stafford is saying, right?
I'm trying to find it for sure, but I'm almost positive it's been found in Hall's Cave, which is weird because this recent story, I'm kind of changing subjects here, but
yeah, the recent paper that came out.
The recent paper by Sun et al.
Yes, yeah, on the volcanic origin for Younger Dryas.
Yeah, they're saying there was
anomalies.
Right. But I'm pretty sure even in this paper they talk about Lonsdaleite. But I can't
use the search function. But yeah, we talked pretty extensively to back and forth with George Howard and Stafford, and he sent us a lot of very interesting information about Hall's Cave. And information on more work that he wants to do in there, and all the possibilities that he thinks it could mean. And we're hoping to get into the cave at some point and maybe even have him give us a guided tour,
Well,
which is
he I seem to recall that he kind of almost volunteered, didn't he?
Yeah.
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 Well, I think Bradley, and I probably speak for both of us, I think we'd like to get in on that if it happens.
Yeah. He said if we could get him down here, then he would be glad to take us out there and show us everything that he's found in the cave and give us a tour.
Now, did he find Lon's Delight?
That's the question.
Stafford, let me see. I was just going to see who he was with. Stafford, number 12. He is with.
He was up in Colorado.
University of Colorado. Yeah.
Yeah.
Boulder.
Stafford Research Laboratories. Okay.
Stafford Research Laboratories. His lab.
Hey, let's go hang out there. Let's do our next podcast from there.
Yeah.
Okay, so that would be very cool. Okay, so we'll pick up with so he's done research in Hall's Cave, and this new study that just came out is also in Hall's Cave.
That's right.
Okay, so we'll talk about that when we come back from break.
All right. We'll be right back. All right, welcome back, everyone. Cosmographia, the Randall Carlson podcast. Monday night. Monday night, not live. Before we get back into it, of course, we're going to get an update from Randall on the CBD oil. How's that going there? Still working out for you?
Oh, yeah. I have been sleeping really good. The only thing that I can really put my finger on that I'm doing different is taking that dose of CBD oil before I go to sleep. And Brad, like we said, Brad can testify that I can sometimes have a hard time sleeping, waking up, laying awake for an hour and a half, finally going back to sleep. Then I got to get up, and I haven't had my full quota of sleep because of that. But I am noticing that I am sleeping really soundly. And
awesome.
So and really it underscores the importance of good sleep, because I've really noticed my level of functioning really can vary with when I'm deficient on sleep. I'm definitely not firing all cylinders.
Yeah. When the body's fatigued, it can't keep up, and then you can't stay healthy. So that's a major deal.
Yeah, I think good sound sleep is one of the prerequisites for good health, no question. Yeah. And certainly for optimum functioning, if I can do really well on 7 hours of sleep if it's good solid sleep. In fact, I've timed it before and come up with 7.2 hours is my optimum.
Now there are some pretty cool apps on the phone that will track your sleep, and you can lay the phone on your mattress.
Oh, yeah.
And so it will detect your motion if you're moving around or any noises, and kind of give you a graph. So it would be interesting. You could actually do a scientific study where you go without it and you track your sleep, and then you go with it and you track your sleep and see what the phone detectors pick up.
So this app on the phone, if you put it on your mattress, then what you're saying then is it can detect whether or not you're bioturbating.
Yeah, that's right.
While you're in your sleep.
That's right.
Okay.
There you go.
CBD from the gods, folks. Check it out. CBDfromthegods.com.
It's the Apollo.
Oh, I should also mention Julia's having great results with her hands and wrists. She's in fact just about used up the whole jar of salve. And really thinking she's getting good results from it, and might even try dispensing with those $3,000 infusions that she's been getting every 3 to 4 months. Who knows? Wouldn't that be something?
Then we can definitely buy a helicopter.
We could. That's exactly what I'm thinking.
Well, we got some other samples coming out to us, and we'll be able to do some reports also. And we do have that code coming, coupon code, for when people do want to purchase some, if they decide to, through the CBDfromthegods.com website.
Yeah. I mean, I had been wanting to really get into CBD for a long time, didn't really know which which one. I mean, how do I know? I mean, I've done research, but it seemed like this just came along at the right time, and so far, so good.
Good deal.
All right.
All right. So, where are we going at this point?
Well, we did have the question about the nanodiamonds in Hall's Cave.
Yes, that's right. Well, what did you find? You were looking at Stafford's site.
Yeah, so I found Stafford, his paper, Testing Younger Dryas ET Impact Evidence at Hall's Cave, Texas. And down here in the abstract, he says, at 151 centimeters... sorry, that's the wrong spot. Okay, the red clays from 151 to 153 centimeters below surface and immediately preceding this contact contained an abundance of nanodiamonds of 5 different allotropes. Aciniform soot at 2400 ppm, magnetic spherules, and carbon spherules, all of which we interpret as evidence for a unique chronostratigraphic marker in the Western Hemisphere.
Okay, let's go through those proxies he found again. He found aciniform soot, which is, we talked about that. That's the grape-like clusters of soot that results from intense wildfires.
Right.
Okay, what else did he find?
Magnetic spherules.
Magnetic spherules. Boy, we've been talking about magnetic spherules, haven't we?
We have.
Most likely the result of solidifying out of a vapor that's in the atmosphere and then falling to Earth, okay?
And it has to be iron, right, to be magnetic, doesn't it?
One would think so. So the spherules he found in Hall's Cave are magnetic.
Yeah, and then also it says, magnetic spherules and also carbon spherules. And 5 different allotropes of nanodiamonds.
Okay, he doesn't name those, does he?
No, he doesn't. It does not in the abstract here, but I probably could find it.
He probably does, yes. Now, given that it's 5 allotropes, I would guess that includes lonsdaleite.
Probably.
Because, I think I can, because I can only think of 4.
N-type and cubic and lonsdaleite, so I got 3, right?
Well, then there's eye diamonds, that's 4.
So
I'm not sure what the 5th allotrope is. Off the top of my head, I don't. Eye diamonds, N diamonds, cubic diamonds, and the hexagonal or lonsdaleite. I don't know what. So I'm going to guess if he's got 5 distinct allotropes, one of those is probably lonsdaleite.
Probably lonsdaleite, yeah.
Okay. So he found those things. So, okay.
Now, in this new paper from July, looking at Hall's Cave by Sun and others, they claim in here that large-scale volcanic eruptions whose explosive conditions are capable of producing molten silica and carbon spherules and possibly nanodiamonds, and in parentheses, lonsdaleite. And then they cite that, which is cited to another paper by
Van Hozel or Hozel.
Yes, Van Hozel.
Right. Now the Comet team has addressed that paper.
Yeah, that was a rebuttal, I guess. The Younger Dryas Impact Hypothesis, a critical review.
Mm-hmm. Yeah.
So I guess they're claiming that lonsdaleite is not exclusively produced by impacts or by extraterrestrial materials.
Right. I would probably say that that's what they're doing, but I think this is a very tentative assumption that doesn't have the kind of support that an impact would, because hexagonal diamonds require a tremendous amount of pressure to form. So that's something we should probably look into. I would like to know how definitive is the evidence that these allotropes can be formed in volcanic eruptions. We know that they can be formed in impacts. We know that they can be formed in nuclear explosions, for example.
Mm-hmm.
Do we know that they can be formed in volcanic eruptions? Are the pressures and heat sufficient? And I don't think that's a settled question at this point.
Okay.
Maybe it is, but I doubt it. I don't think so.
But you were pointing out that the VEI, the Volcanic Explosivity Index of some of these recent volcanic eruptions is greater than what they're claiming in this paper, which is, they were saying 6.3 cubic kilometers.
Which puts it in the range of both Pinatubo and Krakatoa in terms of amount of volume of tephra extruded during the eruption. So, okay, so that being the case, are there any nanodiamonds associated with Krakatoa? I've never heard of that.
Yeah,
that would be
the question.
That would be the question. So I think really, this is something that needs to be tested and explored further. To what extent we could actually associate nanodiamond production with volcanoes, I don't know. Now, what they're talking about in this paper too gets into the isotope ratios of osmium-188, osmium-187, and osmium is delivered to Earth via meteorites has a different isotopic ratio than osmium that's derivative of the mantle. And what they're saying is that the osmium that they're finding is consistent with a mantle derivation and not impact ratio.
Okay.
Which would seem to imply that the osmium is the result of volcanism. But by using the term cryptotephra, they're basically saying we don't know where this came from. What were the possible volcanic eruptions that were going on? Well, there were multiple. There was Glacier Peak. There was Mount St. Helens. Both we know that they were erupting. The Mount St. Helens ash is actually found sandwiched in the mega flood deposits up in Washington State, and has been dated by I believe it's Mayuski. I believe it was him that dated it to 13,000 years, give or take. We've actually found that. Let me see. I have.
But just to make sure, I don't know if we said this, but we were talking about this new paper from July. Just came out. Volcanic origin for Younger Dryas geochemical anomalies.
Right.
In Hall's Cave.
Right. Yes, just came out this month. So.
Oh yeah, look at that.
Let's see. Yeah, I think I have a photograph right here. This, I'm going to do a share screen. This was taken in Washington State. Let's see, where'd you guys disappeared here? Yeah,
Clearly
check that out.
Ash layer, yeah.
Now that's ash from Mount St. Helens. It's called the Set S tephra. And it's sandwiched. You see, these are flood layers. These are back floods, giant back flood, sediment-laden back floods that washed up into the Yakima Valley and then flowed back out. And at the deposition of this layer here, right following the deposition of this layer and prior to the deposition of this layer above it, there was a huge mass of volcanic ash that was settled down. Now, the question is, was this rhythmite layer here, this sedimentary layer, when the ash settled on it, was it underwater or was it exposed to the atmosphere? That's the question. If it was underwater, then it would imply that there was probably really a lot of ash that fell that then had to settle through the water column and then settle out. But I'm looking at this, I'm going, what you've got here is these are backflood sediments. So these actually occurred, let me move this out of the way. Let's see, flood rhythmites on the south bank of the Yakima River near Mabton, Washington. Okay, so this is very close to the limit of the backfloods. So this is going to be a fairly low energy depositional environment. In other words, what you got to picture is that there's a main valley in this flood, sediment-laden flood is rushing down through this valley, but there's tributaries coming into the valley. So as the main flood comes down the trunk channel, it will backflood up into the tributaries. And that backflooding will reach an elevation roughly equivalent with the highest peak level of the flood within the main trunk valley, if that makes sense. Once the water level in the main trunk valley begins to drop, then the water in the tributary valleys reverses and drains back out. And when it does, it leaves sediment behind. Because, again, the sediment load is dependent upon how fast the water is moving. If the water is moving fast, it can pick up and entrain a lot of, in this case, fine-grained sediment. And then as the water slows down, that stuff begins to settle out. So what you've got here is very close to the area where the current did this reversal. This is not there, but it's very close to that point. So you're getting a low energy depositional environment here. And part of the question in my mind is how much time elapsed? And this is a critical question that we have to come back to over and over again in discussing the genesis of these great floods, is that how much time elapsed between deposition of each rhythmical layer? Critical question. Are we talking about years? Are we talking about days? Are we talking about hours? I will say this, that as far as the current dominant models of these floods, there would be years between each deposition of each layer. Perhaps 30, 50 to 100 years. And that is an assumption that follows from the current models of flood origin, which requires repeated damming of the Clark Fork River in the area of Lake Pend Oreille in the northern panhandle of Idaho. So then you have to go and ask the question, how much time elapses between failure of each dam and then restoration of the dam, allowing the lake to refill? And the minimum amount of time is 30 to 50 years. That's the minimum. So the assumption is that each rhythmite represents a separate flood. And I am extremely skeptical of that idea. But within that framework of thinking, then each of these rhythmites, if each of these layers represents a distinct flood, each one of those distinct floods requires a separate filling and draining of Lake Missoula over east in western Montana. Then you're saying that somewhere between 30 and 100 years elapsed between deposition of each of these layers. Now, my question would be, and we're going to come back to this as we really begin to break down the science and research about the megafloods, is this. If you've got 50 years is enough time for a whole, pine forests to become replenished. You're not going to have full 200-foot trees, but you're going to have a lot of vegetation growth in 50 years. In 100 years, you're going to have 100-foot tall trees there.
So you ought to see that in the deposition.
Where is it? Where is the? I would argue that there's much, much closer in time between the depositions of these layers.
Isn't this in the western extent of Lake Lewis?
Yes, this is the western extent of Lake Lewis.
Yes, so these would be the same kind of pulsing rhythmites that would match on the other side of Burlingame Canyon.
That's exactly right. On the other side of Burlingame Canyon is a whole another set of rhythmites, and I will go ahead and we'll take a look here since we're here.
There's the Mount St. Helens layer over there also.
Here we go. Check this out. This is it. Yes. Now you can't see from this photograph that we took in 1998. Let's see, the Mount St. Helens tephra is in here, but you can't really see it in this photograph. What you can see in this photograph is interesting, though. You'll notice that the layers at the bottom are much thicker, and they begin to thin out as you go up. Also, at the top, you've got this roughly 6-foot thick layer of loess, which is a completely different material. This is an airborne. This is a material that's settled out of the atmosphere. Each one of these layers represents if you will, a type of a backwash, a sediment-laden backwash. You see, now this is on, as Brad was saying, this is on the easternmost extent of ancient Lake Lewis, the temporary ponding above Wallula Gap, and Mabton is on the other side. But we're going to be getting into this in much more detail and looking at maps and everything, so people can get the picture. Yeah, here we see another version of a lot of erosion on it, so they're not quite as distinct as you see here. This is the Burlingame Gully. What happened was it in the 1930s? I think it was an irrigation pipe that broke, and for about a week or two, this enormous amount of water under high pressure gushed out of this pipe and cut this canyon here. Well, nobody was really expecting that what was going to be exposed under the ground was all of these rhythmical layers, suggesting that this basin, as far as you see to these hills on the horizon, is part of this Pasco Basin. And so the whole bottom of Pasco Basin is covered in these rhythmical layers.
Wait a minute. A farmer cut that canyon?
Well, no, it was probably, let's see, when I don't know who I don't know if the irrigation pipe was private or government. I don't know.
That's incredible.
Yeah, it was
I
a
would
failed
never
irrigation pipe.
Yeah.
That's,
There's something similar in South Georgia. I don't. You guys lived in
Yeah,
Columbus. but
Providence Canyon. Yeah.
Yes.
Yeah.
That is
was
well, I mean, that's natural though, in the sense that once they started plowing the fields, you remove the vegetation and now you get a lot more surface wash and a lot more erosion. That's what happened in Providence Canyon. Once agriculture started in the late 1800s, that's when the accelerated erosion began. Here, It was just a short-lived event that was probably just like 3 or 4 days before they got the pipe repaired. But in the interim, it has sliced this canyon here, this gully, which exposed these rhythmical layers. Now, this is on the other side, over up in the Yakima Valley. But the interesting thing is that these layers here are going to correspond with these layers here. Now, it was in these layers where it wasn't in these either. We actually, it took us a while to find that outcrop, but it was, like it said, up in Mabton. This is down next to the Yakima River. So these rhythmites here have been exposed by modern river erosion and have been exposed to the atmosphere a lot longer than these. So these are still relatively pristine. Now the question is, how much time elapsed between the depth? There's roughly 40 layers here. So the assumption has been that each one of those layers represents a distinct flood. And each flood represents a distinct damming of Lake Missoula, which means that you have to go through and think through the whole process of how glacier ice could dam and create and then recreate again a body of water with 500 to 600 cubic miles in it that's backed up behind an ice dam, as much as 2,000 or more feet deep. This is an interesting and very sticky problem. And we're going to really get in and look at that, because it's my personal opinion that model is pretty much doesn't make sense anymore for theoretical reasons and empirical reasons. For example, right here is an empirical reason. There's a vertical dike through the whole sedimentary column here. Now, if that dike cuts through, it is more than just a surface feature. You can think of it this way: if you have layers of mud after a flood, everybody's noticed how you get mud cracks, right? Okay, well, if you look at it, you can see that even on a small scale, you'll see multiple layers of mud. And if they're all deposited within one event, not necessarily all exactly at the same time, but within one event, as they dry out together, they will form these vertical dikes that will cut through the entire rhythmical, even if it's only an inch or 6 inches thick. So this thing here, to me, is a very suspicious clue that would suggest that the dewatering of this sedimentary column was taking place not over multiple individual events, but these might have been deposited as surges within a single flood. But we'll get back to that, because, how many floods were there? The original idea was that there was one big flood. Now, according to some studies, there's as many as 90 separate floods. After the study of this and the assumption by the geologists who were looking at this, who assumed or concluded that each layer represents a unique flood, then what that does is they now built a chronology upon that, based upon the duration between the deposition of each layer. So in other words, you have a layer, okay, the layer represents a failure of the ice dam. Then you have to reseal the valley and refill the lake. How long does that take? Well, this is where you get 30 to 100 years. So if you then assume you've got 40 discrete layers, each one is a different flood. Each flood requires the whole cycle to happen. Now you're looking at 2,000, 3,000, 4,000 years for deposition of the entire sedimentary column here. And that's now kind of the working assumption. And it's been buttressed by some optically stimulated luminescent dating and some geomagnetic dating. However, and we get into this, I have reason to question the accuracy of those dates applied to these events, because there's a lot of other evidence that would mitigate against that. Because again, if you had, let's say, 40 or 50 years transpiring between each event, well, you should expect that there should be some pretty mature biome there. There should be shrubs or grasses or small trees, something like that would be preserved between each successive layer. Do we see that? I think the answer is no, we don't really see that. But again, we'll come back to all of this. This is coming up in the near future.
Very cool.
Yeah, back to volcanoes. Yeah, we kind of got off on Mount St. Helens there and the volume of the explosivity index.
But we are moving on to Lake Hind at some point.
Lake Hind.
Yeah.
Lake Hind.
We should come back to this paper though, because this is the latest challenge.
Yes.
To the Younger Dryas impact hypothesis. And I think what I would conclude from my first reading of the paper, and I'm going to have to read again to fully digest everything, but they do make the point that there were multiple volcanic eruptions occurring. I just showed you evidence of a volcanic eruption that is dated very, very close to the Younger Dryas boundary. And that is the one that deposited those layers of white ash that you saw sandwiched between the rhythmites. Glacier Peak, Locker Sea, all of these were clustered, and there's more. There was multiple volcanic eruptions from the Caribbean era. There was several volcanic eruptions that are known to have occurred from Alaska. As Brad kind of was hinting at earlier, I think we could, a safe assumption might be that given the circumstances of the whole deglaciation process and the incredible mass transfer that resulted from that, I would think seismicity and volcanicity would be expected, accelerated. I would think you would see a spike in tectonic response and a spike in volcanic response. And when we started this whole series, and I was kind of getting into using Atlantis as a springboard to talk about some of the geology that was implicit within Plato's account, we saw evidence that there could have been a very significant tectonic response to the eustatic rise in sea level, if you recall that. And then, of course, there was the usual expected comments that, Randall Carlson believes in Atlantis. So, yeah, you shouldn't listen to anything he has to say. He believes in Atlantis. Let me issue a caveat here, if anybody didn't quite get that. All I said was that of all the various possibilities of Atlantis, the original account that Plato gave us is the most logical sense. But I did not say that I necessarily believe that doesn't prove that Atlantis existed. Okay. For the record.
Mike bought it though. He now believes in Atlantis.
Oh, Mike now believes in Atlantis?
Yeah. You totally convinced him. He's a total Atlantis believer now after those series shows.
No, I tried to bring the whole Atlantis thing out of the woo-woo realm and into the, from the, the new age, all that out there. Mike's, constant reference to, what is it, Mike? The
crystal spaceships?
The crystal spaceship,
yes.
Right, the crystal spaceships. Maybe, who knows? Look, but what I was just trying to do was stick to the solid geology, the geography, the oceanography, what we know about those, to what extent are those things consistent with Plato's details? And in a surprisingly consistent way, they correlate, a lot of it. And I did show that, yes, there does appear to have been a massive subsidence along the mid-Atlantic ridge, which would then imply that any islands along the mid-Atlantic ridge are much smaller now than they were during the Ice Age, both because of isostatic vertical adjustment of the Earth's crust and eustatic changes in sea level. But we won't go there. But yes, so my point here being that we should not be surprised that given all of this that's going on, when you're transferring 6 million cubic miles of glacial ice piled up, some cases 2 miles thick on the land surface, squashing that land surface down maybe 1,000, 1,500 feet. And then you're removing all that, you're putting it back into the ocean, and you're doing this on a geological timescale that's almost instantaneous. Yes, you should expect that there's going to be a volcanic response. You should expect that there's going to be a tectonic response. So that we would find evidence of volcanism associated with all that whole transition from Pleistocene to Holocene. Volcanic evidence for volcanic eruptions. How does that refute all of this other evidence? How does that refute the finding of nanodiamonds in the Greenland Ice Sheet? You know, see, nowhere in the article do they actually refute any of the other work. They simply just say that based upon our on our osmium isotopic ratios, we're saying that this is volcanic, and then they speculate that all the other evidence of osmium deposition within the Younger Dryas boundary is in turn also volcanic, and therefore, because if that is volcanic, then it's volcanism that explains the Younger Dryas and not an impact. That's my first reading of the paper, basically. I got to read it again and again. I probably need to read the damn thing 3 times to, and some of it I'm going to have to do a little bit of background. But what they come up with, now this is phys.org, which I'm familiar with, but I'm going to hold this up because I just have it here in my hand, the actual printed paper. And this is how they present it, is Texas cave sediment upends meteorite explanation for global cooling. Does it?
It's upended, man.
Is it upended?
It's over.
It's over. Okay, so we can just forget about those microspherules. We can forget about the iridium. We can forget about the aciniform soot. We can forget about the melt glass. We can forget about whatever, you name it, the nanodiamonds. Let's just forget about all of that. If we find that the osmium material has the signature of the mantle, implying that it is volcanic, as opposed to the signature of meteoritic, now we have disproven the whole impact hypothesis. Okay, here's what they're saying in this phys.org news 2020. The evidence is buried in a central Texas cave where horizons of sediment have preserved unique geochemical signatures from ancient volcanic eruptions, signatures previously mistaken for extraterrestrial impacts. Okay. This work shows, now quoting Alan Brandon, PhD, professor of geosciences at University of Houston, this work shows that the geochemical signature associated with the cooling event is not unique, but occurred 4 times between 9,000 and 15,000 years ago. Thus, the trigger for this cooling event didn't come from space. Prior geochemical evidence for a large meteor exploding in the atmosphere instead reflects a period of major volcanic eruptions. I just don't follow that. And again, I'm going to have to reread the paper to really try to get clear on the chain of logic here. Assuming that they're right, that there are multiple layers, that there are multiple signatures of volcanic events, Plinian volcanoes, which is large volcanoes such as Vesuvius, right? Sometimes called, I think, Vesuvian, Plinian, right? Unidentified, that's why it's called cryptotephra. So they don't know for sure which one. So it's not like actually measuring the ash of the volcano. It's measuring isotopic ratios. Now, apparently what they're saying is that there were multiple layers, they say here, there was the signature with the cooling event is not unique, but occurred 4 times. Well, okay, assuming that it's volcanic, yeah. So there was a volcano eruption 4 times within, 6,000 years. That doesn't seem outrageous to me. That seems certainly plausible.
The other thing that's weird is that one of those eruption events caused the Younger Dryas, but none of the other ones really had any significant effect on the climate otherwise.
That's what it seems to be suggesting. Well, it says the study indicates that the episode of cooling, scientifically known as the Younger Dryas, was caused by numerous coincident Earth-based processes. Well, this is what we were talking about last week or the week before, right? That if you do away with the impact hypothesis, what have you got left? Coincidence. I mean, that's what you got. You got coincidence. So that's what they're saying here. Coincident. Numerous coincident Earth-based processes, not an extraterrestrial. Yeah, I mean, it's starting to seem to me like there's a group of people out there that will do about just anything to get rid of this idea of something from space.
Yeah, like the complex theory for the Carolina Bays.
Right.
You got to string together every geological process you can find to explain them.
Well, here we go. So the Earth's climate may have been at a tipping point. Have we heard that phrase before? Oh, tipping points, yes. May have been at a tipping point at the Younger Dryas, possibly from the ice sheet discharge into the North Atlantic Ocean, enhanced snow cover, and powerful volcanic eruptions that may have, in combination, led to intense Northern Hemisphere cooling. Enhanced snow cover, ice sheet discharge. Okay, now, when we say ice sheet discharge, that brings us right back around again to glacial megafloods and the energy problem. Yeah. Well, to the glacial megafloods and that to the energy problem. Yes.
Yeah.
And he says, this is co-author Michael Waters, PhD. The period of rapid cooling is associated with the extinction of a number of species, including mammoths and mastodons, and coincides with the appearance of early human occupants of the Clovis tradition. Well, my reading of the evidence is, and of course this guy has got to know more than me about it, but my reading of the evidence is the final extinction coincides with the end of the Clovis.
Yeah, I thought that was weird too in the article. It seems to state that that's like the beginning of their appearance.
Uh-huh.
You're also seeing the power of a headline, because the headline's a whole lot more definitive than what they're saying in the paper.
Yes.
And most people are only going to read the headline.
So the University of Houston scientists accomplished the isotopic analysis of sediments collected from Hall's Cave in the Texas Hill Country. The analysis focused on difficult measurements at the parts per trillion on osmium and levels of highly siderophile elements. There's your HSE, which include rare elements like iridium, ruthenium, platinum, palladium, and rhenium. The researchers determined the elements in the Texas sediments were not present in the correct relative proportions to have been added by a meteor or asteroid that impacted Earth. So then from that concluded that they were in the correct ratios to be volcanic. But again, it's as it says here, this is you're getting down to the finest detail of resolution here. Yeah, difficult. The analysis focused on difficult measurements at the parts per trillion. So I don't know how, when you're dealing with things parts per trillion, how reliable can the ratios actually be? I don't know.
It's not the correct ratio for extraterrestrial. I mean, is that can they really say that?
Yes, that's determined.
It's determined.
Yeah, because the ratio has been studied in mantle-derived sources and in meteoritic-derived sources, and it is different. It is, and so the meteorite, the ratio is lighter. So when it's added to the mantle, it will lighten. They actually talk about it in the paper here.
Okay,
but yeah, there's a difference in the signatures, but it's it can be
Always.
it can
There's
be very
always a
difficult to discern that difference. That's the point here.
Well, I'll be interested to see what the Comet Research Group does with this.
Yeah, I'd like to see what Stafford has to say about it.
Yeah.
Yeah.
The signature from the osmium isotope analysis and the relative proportion of the elements matched that previously reported in volcanic gases. So it says Kenneth Beefus, PhD, who is also one of the co-authors, a volcanologist at Baylor University, added that, quote, these signatures were likely the result of major eruptions across the northern hemisphere, including volcanoes in the Aleutians, Cascades, and even Europe. And I think that's probably referring to the Locker Sea volcano, which, hey, I've thought for decades that there's a lot of volcanic activity going on. That picture I just showed you of the Mount St. Helens tephra, we took that and we specifically went to that site because to collect evidence that volcanism played a role in these global changes centered around the Younger Dryas. But I still don't see how this in any way negates or refutes all of the other evidence for an impact.
Right. It's goes back to the question you always ask. Well, what's driving that change?
Yeah.
Right? And they're saying that maybe the ice sheet dumping into the Atlantic or and snow coverage that's what's going to cause all this volcanism.
Increase snow coverage.
It's heavy.
But I think you can kind of see what they might be driving at here. This research underscores that extreme climate variability since the last ice age is attributed to unique earthbound drivers rather than extraterrestrial mechanisms. So yeah, let's keep it all limited to the Earth. Let's not, develop a framework of thinking that encompasses the larger cosmic terrain of which we are part of, inextricably a part of. Volcanic eruptions cause their most severe cooling near the source, usually in the year of the eruption, with substantially less cooling in the years after the eruption. But the Younger Dryas cooling lasted about 1,200 years. So a sole volcanic eruptive cause is an important initiating factor, but other Earth system changes, such as cooling of the oceans and more snow cover, were needed to sustain this colder period. But there again, it sounds tautological to me.
Yeah,
it sounds like circular reasoning to me.
The more snow cover is higher albedo, I think, and
that's what it would be.
More sunlight back out into space, and
and no doubt, changing albedo is going to be a factor in perpetuating.
Yeah,
but if you take away the changes in atmospheric opacity, that is the function of the gases extruded from the volcanic eruption, which presumably, like with Pinatubo, lasted 2 to 3 years. But again, we're talking about the Younger Dryas lasting 1,300 years.
1,300, yeah.
So even if there was, if they say there were 4 volcanic eruptions, is that what it was? Yeah, 4 of them over 6,000 years.
Yeah.
Well, I mean, that gives 1,500 years between each one on average for the effects to wear off. So yeah, they've got a long way to go, I think, to make the case that this is now the cause, and that we can extrapolate just from this study, isotopic study in Hall's Cave, to the entire planet.
Yeah, I recently read a story about the KT event, and there's still a debate as to whether it was the impact or volcanism that was responsible for the mass extinction of the dinosaurs.
Well, and see, to me, that's just a silly question.
Well,
because when you look into it, you've got overwhelming evidence for the impact, but you also have overwhelming evidence for these gigantic basaltic floods releasing huge amounts of sulfur dioxide and other poisonous stuff. And if you look at the Great Five, and again, we're going to get into this because I've developed a whole series of essays around the Great Five mass extinctions in Earth history. And what they all seem to have going for them is both volcanism and impacts.
In this news story that was referencing a paper, these scientists modeled the environment, whatever. They try to run these models, and of course this, it's all models, but they were trying to say that the volcanism couldn't have been responsible for the mass extinction because there would have been bands around, like close to the equatorial regions, that would have still been habitable, whereas the impact winter would have been full scale, right?
Yeah.
And then they said that they went even further to say that the volcanism actually acted as a sort of driver to in a way replenish the environment. So I don't know, just that was an interesting study.
Okay, the VEI, the Volcanic Explosivity Index. So I'm going to share a screen here so that we can all see what this is before we go on. Here we go. So here we have it from the U.S. Geological Survey, the Volcanic Explosivity Index. So we have the number associated with it, right? The scale, the erupted tephra volume, and some examples of eruptions that were in that order of magnitude. And I'm just going to jump down here to Mount St. Helens, May 18th, 1980, because I know some of our listeners are old enough to have remembered that. Let's see. Were you guys Kyle brothers? Allen brothers?
Yeah.
You were here then, right?
Yeah.
Oh yeah, I was studying that. I was 2.
Yeah. Okay. Okay. And Russ, you were how old? You were
5.
5?
I was all over it. Yeah.
Okay.
Wrote several papers.
You wrote. Okay. Well, check this out. Okay. So you can see the circles here. Small eruptions of Mount St. Helens, but then we get to the main one, May 18th, 1980, 1 cubic kilometer. And here you got a circle to give you some sense of proportion. And then Pinatubo and Krakatoa, 1991, 1883, approximately 10 cubic kilometers. So this was, we're saying that according to the Hall Cave study where they were saying 6 cubic kilometers.
Yeah.
Yeah.
What they estimated around
6.3. Yeah.
Yeah. So roughly double than Krakatoa or Pinatubo, which I remember well in 1991, which actually had a discernible cooling effect on the global climate. But then we get into the real good stuff, the 100 cubic kilometers. Tambora, 1850. We're going to talk about that. That's when was followed 1816 was the year without a summer. Sometimes referred to by historians as the last great subsistence crisis of Western civilization. And Mazama, 7,700 years ago. So this circle right here is the 100 cubic kilometers. Long Valley Caldera, California. And then we get to a really big one, which is the Yellowstone Caldera, 1,000 cubic kilometers. That would be an event. If we had a repeat of that, boy, I think humans would survive, but our civilization would not. I think that's a pretty safe assumption.
Yeah.
We would be starting over again from scratch.
Almost from scratch, yeah.
Pretty much, yeah.
And that Mazama is in the Cascade Range there. That's where Crater Lake is in Oregon.
Right, Crater Lake,
surprised
Oregon.
that that's not in their Hall's Cave sediments there. Seems like they would have found that one too.
Well, they didn't mention it that I recall, but that was about 6,600 years ago, I think. Isn't that what it said?
77.
77, okay, yeah. Maybe they've recalibrated. I think I remember it was 66, but that's older, 6,600. So yeah.
That was I was thinking.
What's that?
I was just thinking about Comet Neowise for some reason when you said that. That's 6,800 year periodicity.
Yeah. That's when it's going to come
But
back.
was this the first time it came in, or
I don't know.
we don't really know?
So we're going to wrap it up and we'll have to get into Lake Hind next week.
I guess so. Yeah, because Lake Hind, I wanted to get some discussion about nanodiamonds. And And we've done that. Of course, obviously, there's a lot more we could talk about nanodiamonds and a lot more we could talk about magnetic grains and microspherules and melt glass and all the rest. But we've kind of, I think, over the series of episodes that we've done, we've kind of introduced people to the multi-proxies that are being used by scientists to detect the fingerprints of a cosmic event. And a couple of things that I would emphasize we talked about, I think, week before last, is like the correlation that now where we're seeing where they can complement each other, because particularly the example I used was the microspherules at Melrose, Pennsylvania, being compositionally identical to the rocks of the Lake St. Jean area. And what was interesting about that is we had looked at Lake St. Jean from the geomorphic standpoint and thought, this could be consistent with what we would expect to see with an impact. And that was before we saw the studies on the Melrose microspherules. So to me, that was kind of exciting because it seemed to be very confirmatory that that we might be looking at an impact right there. If not, I mean, where was the impact then that produced those microspherules? Because we saw that if I'm saying it right, the Quebecia terrain is very limited to that area right around Lake St. Jean. And there, look, we can see it right behind Brad to his left there. You see it there?
Oh yeah,
there it is, right there. Yep, there it is, right there. And then Melrose, Pennsylvania is going to be pretty much right down at the bottom of Brad's screen there. So that was interesting. Now Lake Hind, we're going to go to the west, and we're going to see that there are impact proxies there in association with what appears to be catastrophic melting episodes. And that leads us then into looking at the larger scale footprints of cosmic catastrophe.
All right. Can't wait.
What for the
cosmic?
I'm glad
we went over that paper that's, hot off the presses. So that was really cool.
Well, yeah, we're going to be, I think, we're going to be monitoring because I'm sure there's going to be a response to that. And it'd be great to find out what Stafford thinks about it.
Yeah, absolutely.
And you said Young,
Mark
Young, who is doing the bibliography.
That's right.
That would be a valuable thing. Of course, I've done something. I've probably maybe not done it quite as extensive as he has, but I have created a very extensive Younger Dryas reference list. But I go back actually into the 1980s even with it, the 1970s.
Yeah, the Cosmic Tusk has 146 papers.
Wow.
In their bibliography, pro and con, and in between. And I think they do start with the 2007. Wow. That's where it starts.
Yeah, I'm trying to work my way through as many of those papers as I can. I've got a few to go, but I've probably gotten through 2/3 of them. And now I'm ready. But I've, of course, read the abstracts and the conclusions to, I think, to just about every one of those papers. Without diving into the meat of it, I certainly will read the abstracts, so I kind of know what's there. But and then when you're going through stuff like that, there's additional supplementary information and knowledge that you need to have. So one of the things, kind of the sidelines for me, sidelights, if you will, has been learning about all of the unique technologies for detecting the microscale proxies, the energy dispersive spectroscopy, the high resolution transmission electron microscopy. All of that juicy stuff is really interesting to me, how they managed to do it, so we should maybe even devote one of our episodes to just showing some of the technology so people can see what we're talking about when we talk about transmission electron microscopy.
Look at some of that equipment.
Yeah. Wouldn't that be?
Brad's got his hat on now.
Hat's on.
We're doomed.
Good time to wrap. Yeah. whether we want to talk about the Scablands trip a brief minute or not, or the website for a brief minute or not.
Yes, let's do.
What I think is important is we thank the Patreon contributors for that continued support. And
yes, thank you very much.
Randall's brother has taken on some of the management of that, and there are going to be some new things offered. And we should have the video that we mentioned several podcasts ago be provided for them early, and we are pulling another one together to give them first dibs at little excerpts from the show and our break time and our before and after behind the scenes kind of stuff that'll be made available to the Patreon people first.
And we have one, I think, I don't remember whether it's Kyle or Russ will be giving a demonstration of bioturbation.
Either one of us can do that, no problem.
Got some pictures from him when he was a kid.
Digging dirt.
Actually, I have. Never mind.
Yeah. Stop right there, Randall.
So you can still sign up for the Scablands trip. We're not going to cancel it. We may have to postpone it. For now, it's still on. So
yep.
You still got an inkling to do that with us. Go to contactatthecabin.com.
That's right.
And again, those links are in the show notes or the video description. Connect directly to us.
That's right. Everything's in the show notes, or as much as we can put in there. But just in case you didn't know, get a hold of us at cosmographia1618@gmail.com. We do have other email addresses coming. We'll start announcing those on the show soon. But everything else is in the show notes. All the links are there, all the descriptions, keywords. So,
and I just want to say I've got a lot of interesting questions and comments that I'm really trying to figure out. I think once the new website is launched, I've been busy, a lot of time of my spare time consumed creating this new content. Once we launch, I'm going to have more time, and then I'm going to come back and really start addressing some of the many questions and comments that are coming in. Of course, I don't know if I'm going to be able to get to them all because there's a lot, but as I'm filtering through, I'm seeing some really interesting stuff that I do want to pull up, and we should plan on devoting some future episodes to addressing some of those questions and those comments.
Yeah. More correspondence episodes would be great.
Yeah,
definitely will.
Yeah.
FAC. Frequently angry comments.
There you go.
Well, we can address some of those too.
Yeah, that's always fun.
More coming.
All right, guys. Great show.
Yep. Thanks so much.
Thank you.
Great to see all you guys again.
Good night.